Okay, so it's question 2 from week 24 mini test. So a particle is projected upwards, so straight up, so we don't have to worry about it travelling at any kind of angle, with a speed of 15 meters a second. So obviously if I'm taking up, then that's going to be a velocity of 15 meters a second. And then find the total time for which the particle is 10 meters or more above its point of projection. Okay. All right, so particle is being fired up in the air with an initial velocity of 15, and it's really important I'm clear about whether up is positive. So I'm going to take up as positive, which means acceleration will be minus 9.8. So acceleration due to gravity, we always use as 9.8 in maths, and obviously gravity is always going to be working downwards. If I'd have taken down as positive, that would have been absolutely fine. U would have been minus 15 and A would have been 9.8. Okay, so that would have worked as long as you're clear and consistent about whether up or down is positive. So find the total time for which the particle is 10 or more meters above the point of projection. So S is 10, and we're thinking about time. Well, if we think about which Suvat equation would link all those, it's going to be S is ut plus a half at squared. So that's going to be a quadratic in t. So potentially that's going to give me two solutions. And that does make sense because this, the particle. So the particle is being fired up. So it's going to go up, 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 up. It's going to slow down due to gravity. And then it's going to come straight back down again. And what we're saying is, so for this question to make sense, it must reach a height higher than 10 meters. So it's going to have a displacement of 10 meters once on the way up and then again on the way down. Okay, and our question is how long is it higher than 10 meters? So it'll be the difference between those two times. Okay, so let's put the numbers in. So S is ut plus a half a, so a half of minus 9.8 is going to be minus 4.9 t squared. And you are take everything over to the left-hand side. You're absolutely fine just to put that into your calculator, assuming it's not any kind of show that question. So that's how I will do it. So let's put it on my calculator. Okay, so that gives me two values for t. It gives me 2.08. I'm going to go to three significant figures because that's the standard unless told otherwise, or two significant figures would be fine as well because we've only used the value of g to two significant figures. I did there, right. So t is 0.981 if I'm going to three significant figures. So that's obviously on the way up, that's on the way down. So the total time it was above 10 meters is going to be the difference between those. So 2.08 minus 0.981. So I'll write time rather than t because I already used t. So that's coming out as 1.099. So I'm going to round that to two significant figures because, as I said, as I was only using g to two significant figures, that's the most sensible thing to round it to.